ways to combine materials. Others, like David Mueller, are fascinated with a newly discovered treasure, the strongest material ever found, graphene. Made of pure carbon, graphene behaves a lot like a metal, but it's about 200 times stronger than steel and harder than diamonds, even though it's just one atom thick.
Graphene has incredible strength. Combined with incredible strength, it has incredible flexibility.
How strong is graphene? Some researchers estimate it would take an elephant balanced on a pencil to break through a sheet of graphene the thickness of ceramic. Where can it be found? You have to bake it. First, take a piece of copper and place it in an oven. Fill it with a material that contains carbon. David Mueller uses methane, a gas that's a combination of carbon and hydrogen.
We knock all the hydrogen off by heating it up very hot, so it gets turned into just carbon atoms that are floating around in a vapor. Those carbon atoms fall down and bombard a flat surface. So the way to think of this is my copper surface is just like a cold window on a cold day, and then little bits of moisture are in the air and they start to condense onto my cold window, and instead of growing little ice crystals that decorate all the way across my window, I'm going to grow little crystals of carbon that are going to decorate my copper surface. And eventually these little crystals are going to grow bigger and bigger and bigger until eventually they touch each other, and then I have one uniform continuous sheet of carbon, and that will be the graphene.
What makes this incredibly thin layer of carbon so strong? It all comes down to the arrangement of its atoms. When 6 carbon atoms bond, they form a hexagon. And as more and more carbon atoms join the group, more hexagons take shape.
So you can imagine that if another carbon atom comes down and it lands over here, right in the middle, it's got nothing to stick to. It's going to keep rolling around, and then it gets to the edge of the sheet of graphene and says, wait a minute, there's a dangling bond, I want to attach to that, and then it'll continue to grow out, and that's why the sheet gets bigger and bigger and bigger.
Once the baking is done, the graphene-coated copper is taken out of the oven and placed in a solution that slowly etches the metal away. What's left is a small sheet of graphene. Exactly what can you do with a single layer of graphene that's so thin it's barely visible?
So we could imagine graphene would be very valuable for things on the nanoscale.
Because it's both tiny and strong, it could fit inside a cell for medical applications, or be placed in dust for environmental monitoring. But graphene might also have applications on the megascale.
If you could build cables, for instance, for holding up suspension bridges, if you could get to that size scale, then that would open up incredible new engineering